Hello and welcome back. In our previous videos, we have discussed the linear sequence and quadratic sequence in detail. So in this video, we are going to discuss the third type of sequence, the cubic sequences. So let us start it. Before we start the cubic sequences, let us first recap the previous two type of sequences, the linear and quadratic sequence. We know linear sequence is the one where the first difference sequence is a constant sequence, and the quadratic sequence is one where the second difference sequence is a constant sequence. So we have taken two examples. The first is a sequence with terms 2, 7, 12, 17, and 22. So in order to categorize it, first we will find the difference sequence. We know we see the difference between the first pair of terms is 5, and same is the difference between every consecutive pair of terms. So it is a linear sequence. As we see, the first difference sequence is a constant sequence, and the nth term formula for this sequence was a plus d times n minus 1, where a is the first term of the sequence and d was the common difference or the first difference over here. So that was the linear sequence. Now coming to the second sequence, where the terms are 1, 5, 11, 19, 29. So in order to categorize it, first we will find the difference sequence. So the first difference we see, it is 5 minus 1, which is 4, then it is 11 minus 5, which is 6, then it is 19 minus 11, which is 8, and the next difference is 10. As we see, it is not a constant sequence, so we find the second difference sequence, and the second difference 4 minus 6 minus 4 is 2, 8 minus 6 is 2, and 10 minus 8 is also 2. So we see the second difference sequence is a constant sequence, so it is a quadratic sequence. And in case we have a quadratic sequence, we use the formula for its nth term, which is a plus d1 times n minus 1 plus d2 divided by 2 times n minus 1 into n minus 2. This is the first formula we used, and there is another formula we have discussed in another video. So here we know the a is first term of the sequence, and d1 is the first term of the first difference, and d2 is the first term of the second difference. So we can just replace these values, and then there is a simplification which is required with the algebraic techniques. Now we are going to write the formula for nth term of a cubic sequence in comparison with the previous two types, linear and quadratic. We know the nth term formula for a linear sequence was a plus d times n minus 1, and the nth term formula for the quadratic sequence was a plus d1 times n minus 1. This part is just same, d is replaced with the d1, and there is an addition to this term, and that is d2 divided by 2 times n minus 1 times n minus 2, because it is a quadratic sequence. In case of cubic sequence, we see the uh, first part is just same, that comes from the quadratic sequence, a plus d1 times n minus 1 plus d2 divided by 2 times n minus 1 into n minus 2. That is the quadratic part, and there is an addition to it for the cubic term, and that is d3 divided by 6 times n minus 1 into n minus 2 times n minus 3, because it is a cubic sequence. So this is a formula which need a lot of simplification. This is one formula. There is another formula. We will discuss it in some other video. But let us discuss this formula and like find the nth term of the example given below it with the help of this formula. So let us start it. We see a sequence, and in order to categorize, first we will find the difference sequences. The first difference, and 9 minus 1, it is 8. 29 minus 9, it is 20. 67 minus 29, it is 38. 129 minus 67, and that is 62. Okay, we see the first difference sequence is not a constant sequence. So let us find the second difference sequence. 20 minus 8, it is 12. 38 minus 20, it is 18. And 62 minus 38, it is 24. We see the second difference sequence is not a constant sequence. So let us find the third difference sequence, and that is 18 minus 12, which is 6, and 24 minus 18 is also 6. So we see the third difference sequence is a constant sequence, so it will be a cubic sequence. So let us name the terms required over here. We know the first term of the sequence is a. The first term of the first difference is termed as D1. The first term of the second difference is termed as D2, while the first term of third difference is D3 now. So we will replace these values in the formula given above, and it shall now become the nth term Tn equals 1 plus D1 was 8, so 8 times n minus 1 plus D2 was 12, so it will be 12 divided by 2 times n minus 1 into n minus 2. So I am multiplying it first. It becomes n square minus 3n plus 2. And then it is D3 divided by 6. We know D3 is 6, so it will be 6 divided by 6 times n minus 1 into n minus 2. We have multiplied these two terms, and they become n square minus 3n plus 2, and then we are going to multiply it with n minus 3. So now start the simplification of this. So it becomes 1 plus 8n minus 8, and then it is 12 divided by 2, which is 6, and 6 will be multiplied inside, and that becomes 6n square minus 18n plus 12. And then here we can just cancel 6 with the 6 in the denominator, and then we need to multiply these two expressions, and that becomes n cube minus 3n square minus 3n square plus 9n plus 2n minus 6. Now let us simplify this. We see there is only one quadratic term, which is n cube over here. There are some linear terms, quadratic terms, 6n square and minus 3n square and minus 3n square. This shall cancel each other. Now the linear terms are left. It is plus 8n minus 18n leaves minus 10n. Then it is plus 11n over here, so it will become plus n, because it was minus 10 and plus 11n. Now we see the constants. There is positive 1 minus 8, it shall become minus 7. Then it is plus 12, so it becomes plus 5, and there is a minus 6 after it, so it becomes minus 1. So the nth term of the sequence given is n cube plus n minus 1. So this was the method to find the nth term formula for a cubic sequence. This was one method which requires a lot of simplification, but its formula is uh, a little easier than the next method. In next video, we are going to discuss another formula for the cubic sequence.